start with this then. So this is what we started with in our last session, circular measure. We talked about this new angle unit that we have that's called radian. So in a complete circle, in degrees, we have 360 degrees. In radians, we have 2 pi. Okay, so 360 degrees corresponds to 2 pi. What's the definition of radian? This is also very important because this is the only thing for which they specifically say in the syllabus that you need to know the definition of a radian as well. You need to understand what 1 radian is. Let me actually write that here as well. When the arc length of a sector, is equal to the radius of the sector, the angle subtended at the center is 1 radian. All right, so that's the definition of 1 radian. That's how we get 1 radian, that if you have an arc such that the arc length, the length of the arc is the same as the radius of that circle, then the angle that you get in the middle, that's 1 radian. Okay, and then we used that idea to figure out what the total angle in a circle would be, because if the arc length is r, we know the angle would be 1 radian. For the whole circle, the arc length is 2 pi r, the circumference of the circle. So we have to multiply r by 2 pi to get 2 pi r. We do the same with the angle to get 2 pi, that in a complete circle, the angle is 2 pi. All right, so for a complete circle, the angle in radians is 2 pi. Okay, that's what we did. We talked about conversion between degrees and radians. Since 360 degrees corresponds to 2 pi, that means 180 degrees corresponds to pi, 90 degrees corresponds to pi over 2, and so on for the rest of the angles like this. There was a formula that we learned. If you have to convert from degrees to radians, all you have to do is multiply by pi over 180. And if you have to go from radians to degrees, you have to multiply by 180 over pi. So you can sort of remember it this way, that you either have to multiply by pi over 180 or by 180 over pi. So one of the two, right? 180 over pi or pi over 180. Now, degrees are normally bigger numbers, right? Because we said 360 degrees corresponds to what? Only 2 pi radians. 2 pi would be 6.28 something, right? So 360 in degrees is the same as 6.28 in radians. So angles in radians are generally smaller numbers. Angles in degrees are generally bigger numbers. So when we are going from degrees to radian, we want to make the number smaller, right? When we want to go from degrees to radians, we want to make the number smaller. So we have 180 in the denominator in that case. When we want to go from radians to degrees, we want to increase the size of that number, right? In that case, 180 is in numerator. That's one way to remember this. So you either have to multiply by pi over 180 or 180 over pi, right? In order to go from degrees to radians, you multiply by pi over 180. In order to go from radians to degrees, you multiply by 180 over pi. Okay, we did some examples in this. We talked about arc length, how that formula comes from the formula that you did in O levels, theta over 360 into 2 pi r. If you were to do the same thing in radians, in the denominator, you would have 2 pi instead of 360. Then the formula becomes this. S, which represents arc length, that is equal to r into theta. Arc length of a sector is given by r times theta, where theta is the angle in radians and r is the radius of that sector. Okay, just make sure the angle that you're using is in radians here. Okay, that's the only case where the formula works. If the angle is in degrees, this doesn't work. Okay, all right. Then we talked about area of a sector. we again looked at how that formula comes, but this is what the formula is now. Area of a sector is given by half into r square theta. Both of these formulas are given in the formula sheet. S equals r theta, and area of sector is half r square theta. Okay, this is what we did in the last session. This is the main thing that we have in this topic. This is pretty much all that you have in this topic, actually, in terms of new concepts. But then there's some concepts from O levels that you also need to remember. We talked about these ratios, sine, cos, tan, with respect to a right angle triangle. They're defined like this. Sine is perpendicular over hypotenuse, cos is base over hypotenuse, tan is perpendicular over base. Then if it's not a right angle triangle and you have to do some calculation with respect to angles or sides of the triangle, you can use the sine rule or you can use the cosine rule, right? So you need to remember these formulas as well, these rules as well. These are not given in the formula sheet. Sine rule is not given in the formula sheet. Cosine rule is not given in the formula sheet. You need to remember these, okay? I hope you remember these from O levels already, but in case you've forgotten, you need to make sure that you do memorize these as well, okay? All right, so that's what we need to know about. Then we talked about some angles for which the examiner often asks you to give exact answers for sine, cos, tan. Now, you don't have to memorize these. Your calculator gives these values. You just have to make sure whenever one of these values comes in your working, for example, if you have sine of pi over 3 here, you write down what that evaluates to. You can do this on your calculator, making sure your calculator is in radian mode for this. Just put this on your calculator, sine of pi over 3. Your calculator is going to give you under root 3 over 2. It's necessary just to show the step, okay? You can't jump from this step to this step directly. The second last step here is important, okay? So you have to show that sine of pi over 3, this evaluates to under root 3 over 2. Okay, you have to make sure that you show this and then you can write down the final answer after that. So a lot of times you need to do this when they ask you for an exact answer in a question. Okay, whenever they ask for an exact answer, you cannot use decimals in your working. You always need exact values like this. It could be in terms of square roots. Square roots, by the way, are also known as surds. So you might see this terminology somewhere. Surd is another name for square roots. Okay, its square root form is also known as surd form. So whenever they ask you to give your answer in the square root form sometimes or in terms of pi, what that means is your answers need to be exact. Okay, and in that case, your working cannot have anything in decimals. So that's what we need to know about. We talked about area of triangle, how we have two formulas, half into base into height, in which base is one of the sides of the triangle, height is perpendicular to the base coming from the third vertex. Then we had another formula, half into AB sine C, that you use when you have two sides and the angle between those two sides. And we talked about area of a segment as well. Segment is this shaded part. How do you find area of the segment? You subtract the area of the triangle from the area of the sector. So sector minus triangle, that gives you this segment. Okay, we looked at this formula as well. Sometimes you will find the marking scheme they're using this formula directly. Where does that come from? Basically, area of sector minus area of triangle. That simplifies to this. You can do it separately like this, or if you remember this formula, half r square into theta minus sine theta, you can also use this directly if you want. Okay, but it's not necessary for you to remember this. If you just understand that the segment can be calculated like this, that you subtract the area of the triangle from the area of the sector, that's also enough. Okay, so area of sector minus area of triangle. That's what we talked about. And then we talked about the degree and radian mode on your calculator. So you need to be able to switch between the two modes, because a lot of times you have some questions in which you have to use degrees, and another question you have to use radians. So you need to switch your calculator mode during an exam as well. So make sure that you understand that always when you're doing a calculation that involve any angles, always look at the top of your screen. It'll either have D written or have R written on top. D stands for degrees, R stands for radians. You need to be using the correct mode, otherwise you will get wrong answers. And this is a very, very common mistake in the exam, that some students unfortunately do everything right, but they forget to change their calculator mode to the correct one. So if the angle is in radians, they end up doing calculations with degrees. And even with all the working correct, they end up getting wrong answers, which makes them lose a lot of marks. Okay, so make sure your calculator is in correct mode. Okay, then these are all the things that we talked about in the last session. Now, one last thing that you need to remember from O-levels for this topic, and also for equation of circle topic later, is these angle properties of circle. Okay, circle theorems, angle properties of circle. You've done this in O-levels, you will need this for A-levels as well. Now, you might have thought that you might never come across this again, but here it is. Unfortunately, you will need to still know these concepts, still know these rules. Okay, so let's go through some of these again so that you kind of remember what they were, because you will need to use these sometimes in the questions that you find in this topic. So let's start with the first one. The first theorem was, the first angle property was, if you have a chord in a circle, so let's say you have this chord, the endpoints of this chord are here, this point and this point. If these points were making an angle with the circumference like this, and another angle here on the circumference like this, these angles would be equal. Okay, so this property was called angles in the same segment, or you could also remember it like this: angle made by the same chord on the circumference, they are equal. So if this angle is x, this angle here will also be x. You could make any other angle on the circumference on the same side of the chord, that will also be x. Okay, so all of these angles are going to be x. All right, angles made by the same chord on the circumference, they're equal to each other. All right, that was one property that you've done in O-levels. You need to sometimes use this. Then you had angle made by diameter. So if this is the diameter, this side, let's call this AB. If AB is the diameter, the angle made by the diameter on the circumference of the circle is always 90 degrees. So angle made by the diameter AB on the circumference like this is always 90 degrees. Okay, you could make another angle here like this. This is also 90 degrees. So any angle made by the diameter on the circumference is always 90. Okay, so this is what you need to remember. This was how we used to refer to this sometimes as well, angle in a semicircle, because when you have a diameter, the diameter divides the circle into two parts, two semicircles. So that's what it means. Angle in a semicircle is always 90. You can also just remember it like this, that the angle made by diameter on the circumference is 90. But not just this. This property also gives us a couple of other things. And that is, apart from the diameter, no other chord can make a 90 on the circumference. So it's also true the other way around. If angle is 90, that means AB chord is diameter. So it works both ways. If you know that AB is diameter, then the angle would be 90. And if you know the angle at the circumference is 90, angle made by a chord on the circumference is 90, then this is supposed to be the diameter. Then that chord is supposed to be diameter. Only diameter can make 90 degrees on the circumference. No other chord can make 90 degrees on the circumference. Is that okay? This is important. Only diameter can make 90 degrees on the circumference. I'll actually just write it like that. Only diameter can make 90 degrees on circumference, which means no other chord can do it. No other chord in a circle can make 90 degrees on the circumference. So if the angle is 90, that ensures that that line is a diameter. Okay. Then also, if you have a diameter, now these are all interlinked properties. In fact, it's just an extension of the same property, but you need to use all of these things that I'm telling about. If AB is a diameter and you have an angle outside the circle like this. So for instance, if you have this angle, an angle outside the circle. Can you say anything about this angle? Anyone? I'm sorry, my straight lines are not very straight here. Let me try if this works. No. Okay. Okay. Can we say anything about this angle? Let's call this angle X. Is there anything that we can say about X? Is it greater than some value or less than some value? Any idea? Remember, angle at the circumference is 90. What about the angle outside the circle? Abdullah, you're saying something?
Sir, this angle will also be 90.
This will also be 90? Well, think
Sir,
about it.
it is making Z. Have
If the angle was at the circumference, this would be 90. But now the point has gone outside the circle. Can that also be 90? Is that possible? If the point is outside the circle like this, you would say that angle is less than 90, right? Because it becomes narrower, right? So it will become clearer if I make it way outside the circle like this. You can see this angle is much lower than 90. So if the point is outside the circle, the angle made would be less than 90. Angle made by diameter would be less than 90. And if the point was inside the circle, if I had this point, what about this? If I call this y, y would be more than 90. So at the circumference, it's going to be 90. Inside the circumference, inside the circle, it's going to be more than 90. Outside the circle, it's going to be less than 90. We're talking about the diameter. If AB is the diameter, then the angle made outside circle would be less than 90. Angle made inside circle would be greater than 90. Angle made at the circumference would be equal to 90. Is that okay?
yes, sir.
Okay, let's move on to the next one. Then this is another very commonly used property here. If you have a chord, this is a chord, and a line comes from the center of the circle to the midpoint of that chord, the angle made is 90. So if center of the circle is joined with the midpoint of a chord, the angle that you get here is 90 degrees. And it's also the other way around. If this angle is 90 degrees, if the center of the circle makes 90 degrees with a chord, then this point has to be the midpoint. Okay? So if you know M is the midpoint, angle is 90. And if you know the angle is 90, M is supposed to be the midpoint. It's a very commonly used property in this topic as well, and also in equation of circles.
Sir,
So you need to make, yes.
sir, then will the chord be divided into two equal parts?
Yes, two equal parts. So if M is the midpoint, the right hand side and the left hand side, they're equal to each other, the lengths, yes. Right? So if I have another chord, for instance, if I have this chord here, if I make a 90 here, then this point is definitely the midpoint. N is definitely the midpoint, and the chord is divided into two equal parts like this. Okay, so whenever the angle is 90, that point is midpoint. If the point is midpoint, the angle is 90. We're talking about a line coming from the center of the circle to a chord. Okay, make sense? Let's move on. Again, another very commonly used one. tangents coming from outside a circle, from a single point. So let's say I have this point P. I have this point P. From that point P, I have two tangents coming. One is touching the circle at this on this side. The other is touching the circle on this side. Okay, there are two tangents that are coming to the circumference of the circle like this. Now, there are a number of things that are true about these two tangents. Number one, these two tangents are always equal. So you can say PQ is equal to PR. So I'm talking about this orange one. PQ is equal to PR. Make sense? PQ is equal to PR. These tangents are equal. But then there are a number of other things that are also true here. Whenever you have a shape like this, that you have a point outside the circle, and from that point outside the circle, you have two tangents coming, the first thing you're always going to do is, to help with your calculations, you are going to join these points with the center like this. Now, assuming the center is point O, then OQPR, this figure is a kite. This figure is always a kite. Okay? This figure is always a kite. OQPR, this is a kite. So all the properties that you have for a kite apply to this. Now, you know that PQ is tangent, OQ is radius, and radius make 90 degrees with each other. So these angles are 90. You're also going to do another thing. Once you're done with making the kite here, you're also going to join these points, O and P, like this. OP is the line of reflection. Like with any kite, one of the diagonals is the line of reflection of that kite. In this case, OP is the line of reflection, which means if this angle is X, this angle is also X. And that also means if this angle is Y, this angle is also Y. So the angles are going to be divided equally because OPQ and OPR, these are congruent triangles now. These are exactly equal to each other. Okay? So this is what you need to now know about tangents coming from a point outside the circle. If you were to join the points Q and R in this case with the center, the shape that you get is going to be a kite, and all of these properties are going to be true about that kite. Make sense? Okay, next one. The angle at the center of a circle is twice the angle at the circumference, right? So if you have a chord like this chord, the endpoints of this chord are making one angle at the circumference, right? If that is X, they're making another angle at the center. If this is O, the center, the angle at the center is going to be 2 times X as compared to the angle at the circumference. If the angle at the circumference is X, the angle at the center is going to be 2X. Okay? If you had something like this would also be X, right? Because this is the angle at the circumference, and that's going to be the same as this. But the angle at the center is going to be 2 times that. Okay, this was another property that you did. Angle at the center is twice the angle of the circumference. Then we had this property, cyclic quadrilateral. Remember this? What is a cyclic quadrilateral? Quadrilateral is a figure that has 4 sides. A cyclic quadrilateral is one that has all of its vertices, all of its corners lying on the circumference. Okay, lying on the boundary of the circle. This is the cyclic quadrilateral. Now, for a cyclic quadrilateral, we know that the opposite angles are supplementary. Supplementary means they add up to 180. So if you knew that this angle, for instance, is 120, then the other would be 60. Although it doesn't look like 60. Let's say if one was 110, the other would be 70. Okay. And if this one was, let's say, 100, the other would be 80. So the opposite angles need to add up to 180 for a cyclic quadrilateral. Cyclic quadrilateral is a four-sided figure that has all its vertices on the circumference of the circle. Okay. And then finally, if we have a tangent and a radius, they make a 90 degrees with each other. The angle between a tangent and a radius is 90 degrees. Okay. So these are all the properties that you need to know about. You've done all of these in O levels. There are some that are used more than the others. So that's why some of them have stars with them. So this one, the diameter one, this is used very frequently. Angle made by diameter is 90 degrees, along with the other details that we did. That if the diameter makes an angle outside the circle, that's less than 90. If it makes one inside the circle, that's greater than 90. And only diameter can make 90 degrees. Any other chord cannot make 90 degrees at the circumference. Okay, that's what we talked about. That's an important property. This one is very important, that if you have a line coming from the center of the circle to the midpoint of a chord, the angle is 90 degrees. And if the angle is 90 degrees, the point is the midpoint, right? Both ways. This is an important property. And then this one, tangents coming from outside the circle, the kite figure that you have. And this one, the tangent is perpendicular to the radius. These four are used more common. You still need to know the rest of them as well, but they're not used as commonly. Okay. The ones that have stars with them, the four properties that have stars with them, they are more important because you'll find them more frequently in past papers. But a general rule is that anything that you've done in O levels, they can test in A levels as well, because of course they expect you to know all those concepts in A levels as well. Okay. But generally, these are the four properties that they test more. Any question on this? Any question on this, anyone?
No, sir.
Sir, the one that you have crossed out, is that not in the syllabus for AS?
Uh, yeah, so this is not part of the syllabus. See, this was not in the uh, O level syllabus as well, and it's also not needed in A levels. You can actually do anything, everything from using the other properties. This is not part of syllabus. Okay, it's the exterior angle property. It was not part of the syllabus in O levels as well, and it's still not part of the syllabus. Okay. All right. So if there are no questions, that's pretty much all that we need to know about this topic. Now, I asked you to do some questions from the worksheet. I hope you have attempted some of them. Let's try at least one of them right now, maybe two, that you had problems in. How many of you attempted at least three questions from the worksheet? Can I raise your hands? At least three questions from the worksheet. That's a pretty low benchmark, but still, only four of you have done that. Again, it's really, really important that you do practice, because only then you'll realize where you're getting stuck. You'll ask about those problems. So, okay, so make sure that you spend this weekend then and complete the worksheets and revise everything. That's really important. Okay, so those of you who did attempt questions, let me know if there were any particular problems so we can discuss them.
Sir, can you do question number 14?
14. Okay, let's start from that. Question number 14. Let's start from this one. Not here. Okay. Question number 14 from the worksheet. Let's try this one. Okay, before this, I actually would do an easier one as well. So we'll do 2 questions. One easy one. So those of you who haven't done anything, at least you start understanding what's going on. Let's do a very simple one first, just in a few minutes, quickly. Yeah, let's start with this one. Question number 6. It's not very difficult. It's just that they want an exact answer. Let's start with this, then we do 14. Okay, so we'll do these 2 questions and then we end. Let's start with 6. Okay. Or maybe when you start, you can start from this one. Question number 1 is probably the simplest, and 2 as well. Let me actually do an even simpler one. 2, or this needs an exact answer. Number 1 does not need an exact answer. Okay, so this is pretty straightforward, I think. Yeah, let's do this one. Question number 2. Let's do this, and then we do the one that I'm asked about. Then you can let me know if you have other problems in the next class. You'll be spending your weekend on this. Question number 2. Okay, so it's a simple one. It should not take too much time. Then we do the other one. Okay, so it says in the diagram, AC is an arc of a circle. AC is an arc of a circle. Center of that circle is O. Radius is 6 centimeters. The line BC is perpendicular to OC. And OAB is a straight line. Is a straight line. Angle AOC is pi over 3 radians. Find the area of the shaded region, giving an answer in terms of pi and under root 3. Now, whenever it says give your answer in terms of pi, under root 3, under root 2, or anything like that, all that means is that you need an exact answer. Just make sure that you do not convert any numbers to decimals, and you would automatically get the form that they want. Okay, so you don't have to actively try having pi somewhere or under root 3 somewhere. It'll automatically come. Just make sure not to write any decimals. Okay, use exact values. You'll get this form automatically. Okay, now let's think about this. We need the area of the shaded region. First of all, you need to understand how to describe that shaded region that you have. So how would you describe the shaded region? From what area should we subtract other area to get the shaded area? What do you think? Can you describe that in words?
The area of the triangle minus the area of the arc.
Area of the triangle minus area of, not the arc, area of the sector. Arc is just this line. Okay, so line does not have an area. Arc is just line. This shape is called a sector. So area of the sector. So area of triangle minus area of the sector. That will get us the shaded region. So that's all that we have to do. We say shaded area is equal to area of the sector minus the area of the, the other way around, area of the triangle, because the triangle is outside, that's bigger, area of the triangle minus the area of the sector. Now, how do you find the area of the triangle? You know this side is 6, but you don't have any other side. So what do we do now? Can we find another side? We have this side and we have this angle, but we don't know either OB or BC. We need at least one of those 2 sides.
Sir,
Can we find
trigonometric ratios.
trigonometric ratio, right? It's right angle triangle. We have an angle and we have the side. So with respect to this angle, 6 is the base or adjacent. If we can find BC somehow, we could use that as height because it's a right angle triangle. If we use 6 as base, we can use BC as height. So we can use half into base and height. So we can find BC like this. We can say BC is perpendicular. 6 is base. What's the ratio between perpendicular and base? Ratio between opposite and adjacent? It's tan, right? So we say tan of pi over 3, that should equal opposite, which is BC, over adjacent, which is OC. right? OC is 6 centimeters. We can write 6 there directly. And now we can find BC from that. Tan pi over 3. Do that on your calculator, making sure your calculator is in radian mode. And it should give you under root 3. Okay, do that on your calculator. You should get under root 3 from that. So you get BC over 6 equal to under root 3. And that is BC equals 6 under root 3. That's the length of BC. Okay, so we have the side now. 6 under root 3. Now, what's the area of the triangle? It's half into basic divide. That's half into 6 into 6 under root 3. You can simplify this, making sure not to write any decimals. 36 over 2 is 18, so that's 18 under root 3. That's the area of the triangle. Okay. What about the area of the sector? What's the area of the sector formula? Half r squared theta. Well, that's just half into r squared. R is 6. So we can say 6 squared into theta in radians, remember? This is already in radians. That's pi over 3. And that's it. You can just simplify this now. 36 over 6, which is going to be 6 minus 6 pi. And that's the area of the shaded region. So these are probably the easiest 5 marks you would find on this topic. That's all that you have to do. 18 under root 3 minus 6 pi. Make sense? So remember, arc length formula is S equals r theta. Area of sector formula is half r squared theta. Okay. We are using this for the area of the sector here.
Sir,
Yes.
sir, it says the answer should be in terms of pi, but it is 6 pi. We should take 6 common.
No, this is in terms of pi and under root 3. If you have 18y minus 6x, isn't this in terms of x and y? It is. As in, it's not necessary that you can't have a coefficient with x. You can. That's perfectly okay. In terms of pi under root 3, just means that in your answer, you need to have under root 3 somewhere and also pi somewhere. Okay. So you have pi here and you have under root 3 here. Okay, so that's the area of the shaded region. That's what you have to do in this part. Now, let's look at this one. Question number 14. It says the diagram shows 2 circles, C1 and C2, touching at the point T. So we have 2 circles, one big circle, one small circle. They're touching at this point T. Circle C1 has center P and circle C2 has center Q and radius 2 centimeters. So the smaller circle has radius 2 centimeters and the bigger circle has radius 8 centimeters. It's shown in the diagram as well. Now, it says points R and S lie on C1 and C2 respectively. Remember, C1 and C2 are the names of the circles. One circle is called C1 and the other is called C2. R and S are these points. And RS is a tangent to both the circles. Okay, so that's the diagram. They just described the diagram in these first 2 sentences. And the first part, what we have to do is we have to show that RS equals 8 centimeters. Remember, whenever you have a question like this that asks you to show something, whenever they ask you to show something, that means is you have to show complete working. You only get marks for the working, right? So you need to make sure that you show all steps in your working. What we want is RS. RS is this length. How do you find RS? Can you make any triangle that you can use here? Do we have any angles? Do you have any information that we can use? Any idea?
We
Sir,
have that.
we can make a right angle triangle.
Right angle triangle, this triangle or this triangle? Which triangle?
No, sir, from Q to like the PR line.
Yeah, so that's very good. We want to find this length, RS, right? Now, RS we used to make this triangle. Okay, but is that going to help? We have only one side of this triangle and no other information. That's not going to help. What else we could make? Maybe this triangle. In this, we have this 2 centimeters, but no other information. That also not that's also not going to help. Another idea is we say, let's draw a line from PR to Q like this that is parallel to RS, right? This horizontal line. Now, whatever is the length of RS, the length of this horizontal line that we have drawn ourselves is going to be the same as that. We could call this point something. This is Q. Let's call this point maybe X. XQ is going to be the same as RS. Now, if we can find XQ somehow, that will be the same as RS. Now, how do you find the length of XQ? What's the length of PX? The length of PX would be 6 because this complete length is 8 and the lower part is 2. Part is 2. So what's left above? It's 6. And if you look at this length, what about this? PT is the radius of the bigger circle. That is 8. PQ is the radius of the smaller circle. And that is 2. What's the complete length PQ? That's 10. All right. So we have a right angle triangle now in which we know PX is 6, PQ hypotenuse is 10. We can find XQ. How can we find that? We can say XQ squared, base squared, plus perpendicular squared equals hypotenuse squared. That's 10 squared. Which triangle are we using? We're using the triangle PXQ. Now we can find the length of XQ from this. XQ squared equals 100 minus 64, that is 36. I'm sorry, 100 minus 36 is 64. And XQ turns out to be 8 from this. That's what we were looking for. And if XQ is 8, that means PS is also 8. Sorry, RS is also 8. Is that okay? That's the first part. So you have to make sure that you show this working because this part already has the answer given. So the marks are only for the working. All right, so now what's next? Next, they ask you to find the angle RPQ. What's that angle? RPQ angle is this angle. We're looking for this angle. We want to find this angle in radians correct to 4 significant figures. Remember, the general rule is you want at least 3 significant figures in your answers. You can write more than that, but not less, which means at least 4 significant figures in your working. So your working always has to be minimum 4 significant figures if you're writing numbers in decimals. But if the question says something, in this case, the question statement says you need your answer correct to 4 significant figures, then you have to follow the instruction exactly. It says 4 significant figures, then it means 4 significant figures. If you write 5 in your answer, you lose a mark. If you write 3 in your answer, you lose a mark. Okay. Now, if you want your answers to be correct to 4 significant figures, your working has to be more accurate than that. Then you will get a correct answer to 4 significant figures. So your working should be correct to at least 5. So more than 4, basically, at least 5. That's what your working should be. So keep that in mind. Now, RPQ, that's the angle that we're looking for. Let's call this angle theta. How can we find this angle now? Well, it's pretty straightforward. We have a right angle triangle already. We know all the sides in this triangle. We can use any of the ratios, sine, cos, tan, to find that angle. Let's do that. Part 2. Again, we could use the triangle PXQ. In that triangle, we can say we know, according to this angle, We know the side that is adjacent, which is 6. Adjacent is 6. 8 is hypotenuse. What's the ratio between adjacent and hypotenuse? Sorry, hypotenuse is 10, sorry, not 8. This total hypotenuse is 10. This side is 8. So you can use any ratio. You can use cos, sine, or tan. Let's use this. In fact, that would be less confusing. This is 6 and this is 8. 8 is perpendicular or opposite. 6 is adjacent or base. What's the ratio between adjacent and opposite? It's tan. Tan of theta is opposite, which is 8, over adjacent, which is 6. That's going to give us the value of theta. So tan inverse of 4 over 3. That's all that you have to do. What do you get from this?
Zero point nine two seven 0.9273.
0.9273. The last number has to be properly rounded off. Okay. So that's 4 significant figures, 0.9273. Make sense? All right. Okay, let's look at the third part. It says find the area of the shaded region. Now, how would you describe this shaded region? From what figure do we subtract or add some figure to get the shaded region? Any idea?
Sir, trapezium minus 2 sectors.
Trapezium minus 2 sectors. So we have this trapezium, right? We can find the area of this whole trapezium. Subtract from that the area of this sector and the area of this sector, right? Let's start with the area of the trapezium first. What's the area of trapezium? You need to remember this formula. It's not given in the formula sheet. Area of trapezium is given by half into sum of parallel sides into height. So area of the trapezium, what's that trapezium called? PRSQ. PRSQ. Half into sum of parallel sides. What are the parallel sides? One side is 8 and the other is 2. Right? These are the parallel sides. 8 plus 2. Into height. Height of a trapezium is the distance between the parallel sides. That's RS. And we know that is 8 now. So into 8. That's the area of the trapezium, which turns out to be 80 over 2. That's 40. Okay, so that's the area of trapezium. What about the sectors now? We have one sector here, PR. One sector, right? What's the area of the sector PRT? Let's find that. Area of sector PRT. Remember the formula, half r square theta. Area of sector is half r square theta. What's the radius of the sector? The radius of the sector is 8. Angle is theta, which we have found in the previous part. That was 0.9273. So all you have to do is half into 8 squared into theta. That's 0.9273. What do we get from this? What's this value?
Uh, 29.6736.
29.6736. So we can say 29.674. Okay. All right. Then we have area of this sector. We know the radius of this sector is 2, but the problem is we don't know what the angle is. How do you find the angle of this sector? We want this angle. Any idea? What's the sum of angles in a quadrilateral? 4-sided figure. What's the total angle? Yes, Rajal?
360. We have to minus the pound angle by 360.
360. But remember, we're working with radians.
So 2 pi.
2 pi. So the total angle, the sum of all angles in this trapezium, in this quadrilateral, that is 2 pi. So if we were to find this angle PQS, we could say the total angle in the trapezium is 2 pi. We subtract from 2 pi. This 90 degrees is pi over 2. This 90 degrees, again, in radians, that's pi over 2. And we also subtract theta, which we have found to be 0.9273. And that will give us that angle that we're looking for. Okay, what's this angle?
2.215.
Okay, so that angle is 2.215.
Yes, sir.
Okay, now area of the sector SQT, that's half r squared theta, half into 2 squared, that's the radius, into theta, that's 2.215. And that will give you this area. What's this area?
Four point four three.
4.43. We want more accuracy. Remember, minimum 4 significant figures when you're working. 4.4.
That's the entire answer. That's the entire answer.
Okay, 4.43. Okay, all right. So now all you have to do is subtract from trapezium the areas of those two sectors, so minus 29.674 and minus 4.43. And that should give you the shaded area. So from that complete trapezium, we are basically subtracting these two sectors. Okay. So what do we get from this now? 40 minus 29.674 minus 4.43, that you're saying is 5.896. We could round it off to 5.90 because that's our final answer now. This is the shaded area that we were looking for. Okay. Any questions on this? Please make sure that you complete this worksheet over the weekend now. Also submit the previous worksheets. That's really important. And just an announcement, next week, we actually have elections in Pakistan. So it's very likely that there would be internet disruptions. So it is possible that next week we might have to do our classes on a different day from the ones that we have scheduled. So we will keep the days Monday, Tuesday, and Thursday for now. But in case the internet is not working on Sunday, we might have to shift that class to another day. Monday, Tuesday, hopefully would be fine. But Thursday is the election day itself. So I'm pretty sure on Thursday it's not going to work. But for the other days, in case we have a problem on Monday or Tuesday as well, we might have to shift that class to another day. All right, just keep that in mind, just a heads up. It is possible that we might have to change the days next week. All right. Okay, any quick questions before we end?
No, sir.
No? All right, that's it then. I'll see you again on Monday. Please make sure to submit the worksheets. That's really important. I love this.